So in NumPy mode, there are two decorators, very important. The first decorator is JIT, the second is unJIT. So the N here is stands for no Python. What the no Python means? Actually, it means under this mode we can't have any Python object which is not allowed by Numba in our code. And Numba actually support most of the Python feature, and it will support most of the NumPy feature. But some Python object like the pandas series or pandas data frame or some object from other package, they are very they are not supported by the Numba, so we can't use them in the NJIT. So basically, we will use Numba to process some array computation task. So I think the NumPy is enough. If you want to deal with the pandas series or data frame, you can first transfer or change it into NumPy series. Then it can be processed by the Numba. So we will see what's the difference. So in the first example, we construct a series from pandas, and then we double the series. It's very simple, and we will benchmark the time, and we found it take us 59.6 milliseconds. And we will also benchmark the JIT version. So after we mark a JIT decorator on our function, we call our function number version is number series, and basically the code inside the function is the same as the normal Python version. So we will also test. So here we actually we before we test we execute our function. So because the first time called function number will have a compile time which cannot be considered in the time benchmark. So we can see that they are actually very similar. So no performance improvement with JIT. But what about when we use the NJIT? So after we add the NJIT decorator on our function, actually the code raised an error. It tells us Python object series is not allowed in the NJIT. So you see that non-Python mode cannot support most of the Python object. Of course, expect NumPy and some Python, most of the Python feature. Okay. So now we still take the example that's double our array. That we will pass an array into our function, then use a for loop, then double our array. And we can find that if we use the number, it will take us 11.1 milliseconds. And if we use the NJIT and the for loop version, actually we only take 3.31 milliseconds. It is much more faster than the NumPy version. So in Python, when we write some for loop, it will be slow, but you should know that it will be very fast if we write some for loops in the NJIT or no Python mode. Okay, this is a very simple example. Then we will show a more complicated example. Not too complicated, of course, but most advanced than this example. So we are given n data points, that is x1 to xn, and we have the p of xi, and I is from 1 to n. What is pxi? That is the normalized value over all data points. That is px1 is x1 divide x1 over sigma xi. So that is a normalized value. So the sum of pxi is equal to 1. Then we will define the entropy. The entropy is defined by the following formula, that is negative sum from I to n and pxi times log pxi. Then we can, in the NumPy version, we can easily write the answer. So the scaled or normalized array is the original array, and divide the array dot sum. And if we want to get entropy, that is actually the scaled array times the log array, a scaled array, and we take a negative on this. Then we will add some more. Okay, we benchmark our code that it will takes us 15.4 milliseconds, and we will write this function according to for loop. So we are 4 I arrays, and we will have a total, and we will add this I divide I over total, and we will have the I over total times log I over total into the entropy, and return negative entropy. The whole process is the equivalent to the original strategy, but we find that there is a huge performance enhancement, that will only take 8 milliseconds rather than the original 15.4 milliseconds. So actually, we can use some advanced settings to accelerate our code. For example, we can use fast math. If you want to use this setting, you have to install the ICCRT package that can be installed by the conda install, and you will choose the channel as Numba, and the package name is ICC underline RT. So what we only need to do here is to add a parameter or keywords into the decorator. So we can see that our the code speed is accelerate. It only takes us 2.95 milliseconds. And if we want to go faster, so we can use the parallel setting and use p range instead of the normal range. And here we will import the p range from Numba and add the parameters that parallel equals to true in the keyword setting. And then we just do the normal stuff. And then we still benchmark, and we find it only takes us 0.764 milliseconds. That is much more faster than the original one. So there is some construction on the parallel mode. So if we set the parallel to true, some operations are not allowed. So what is valid, what is invalid, you can check the full list from this website. It actually is the official document from the Numba. So here I will talk about support operations in the p range. Okay. Then here is an example. Even we don't have a for loop, but the numpy.log it can be much more faster if we've set the parallel into true, much more faster than the original NumPy version. Okay. Also, we just mentioned that some objects may not be allowed in the non-Python mode. So we want to know what kind of what objects are allowed in the non-Python mode. For example, we have the dictionary expression in the return value, but actually it raise error called tells us this Python feature is not supported in the non-Python mode. And we have the array.diff. Diff is an function on the NumPy, original NumPy, but this is also not allowed in the non-Python mode. It will also raise error. So we can check what is allowed for Python feature at here. It's called supported Python features. Yeah. We just show an example that this is a dictionary generator. So it says the set dictionary and the generator expression comprehensions are not supported. So, and we also can check whether this diff function is allowed. We can check from this website. We'll search diff, and we found a diff, but we should notice that it is a function on the NumPy module, not the attribute on the object itself. So we can only call np.diff instead of the array.diff. So they are different actually. So we can find that if we use numpy.diff, it can be done very in a normal way. So this is a correct results. So this is some tips when we use the non-Python mode.